Alright, so these are going to be our notes for Unit 6. So if we go ahead and get going here. There we go. Alright, so we're going to be solving systems of equations here. We're going to start off with linear solutions. So for our first one here, we have use the graph to solve the system of linear equations, then check the solution algebraically. So if we're given a graph here, we're just going to go ahead and identify it. So there's a couple different scenarios here. We either have one point of intersection, such as here, where we see the graph and the two lines meet at a single point. So with linear equations, we either have one solution, infinite solutions, or no solutions. So one solution is here where they intersect. So the coordinates of this point are 2, -1. Okay, we have already covered graphing linear equations, so at this point is review. We're going to graph using GeoGebra in this course, so let's go ahead and take a look here. So both of these are already solved for y. So let's go ahead and use GeoGebra to solve them. So my first equation is -x minus 2. So let's go ahead and graph that. So I have -x minus 2. And real quick, it's going to freeze for a second here. Hold on. There we go. So what else I did here, in case you didn't have it like this, is I right-clicked and hit axes and grid. That way I can go ahead and see these as well, where the graph goes. So that's our first graph. Now for our second equation, we have 2/3 x plus 3. So always put your fractions in parentheses. 2/3 x plus 3. And check. They look the same. We're good. And here we see our point of intersection. So it's going to be at -3, +1. So our solution there, -3, +1. So moving on from there, at this point, what we want to do now is we have a different equation that's going to be in standard form. But what's nice is GeoGebra can actually handle that as well. So we have 5x plus 4y equals 16. So I deleted what I had here. So 5x plus 4y equals 16. Press enter. And for our next equation, x minus 4y equals 8. So x minus 4y equals 8. And we'll see our point of intersection is here at 4, -1. Alright. This one's the same thing, so we'll leave these up to optional practice. Again, at this point, when we're given a problem that is solved graphically, we can just utilize GeoGebra to graph those for us. Moving down here. So this is going to be, actually we are going to skip this. Alright, so substitution should be a matter of review. You guys have seen that in the past. So what we're going to focus on is solving by elimination. So if we go ahead in here. Alright, so we'll notice with these is no variable is solved by itself. Right? Now if you know substitution and you see equations like y equals, you're welcome to use it. What this video is going to focus on is utilizing elimination. So here, I'm looking at my variables. Now, the key of elimination is we want to pick either x or y, and then get rid of it. So, if I look here, I have a 4 and a 2. So those are both positive. They're not the same number. Here, I have positive and -3y. Now, the reason I'm going to use y here is because they're the same number, but opposite signs. So some problems will involve a little bit more work. But for here, we're already good to go. So you'll notice also I'm in the form my x's line up, my y's line up, and my constant numbers line up. So here, if we think about adding these equations together, we add down. So 4 plus 2 gives me 6x. 3 and -3 give me 0, so they cancel out. Here, I'll get 24. Now, that idea of canceling out is where elimination comes from. It tries to eliminate a variable and get one by itself. So if we divide by 6 here, I'll get x is equal to 4. And then I can plug that into either equation to find my y value. So I'm just going to use the top one, so 4, and I'm plugging in my x. So I get 3y is equal to 0, and I divide by 3, I get y equals 3. So my answer is, oops, I lied, we get 0 there. So our answer would be 4 from x, 0. Moving on to example 2. All right, this one's going to require a tad bit more work because we notice our bottom equation looks good, but our top one doesn't have x and y on the same side. So to get my y over here to line up, I would have to subtract it. So I look, my x's are both positive, different numbers. Let's check my y's. Again, we have a positive and negative 2. So I can go ahead and do elimination by adding. So 3 plus 5 gives me 8x. My y's cancel, and it's equal to 20. I divide here. If we use GeoGebra in our fraction text command. So let's go ahead and just do that. So fraction text. I want 20 divided by 8. We notice that comes out to 5 over 2. And then I'm going to go to the first equation. So 3x minus 2y. Move this up a bit. So my x is 5 over 2 minus 2y equals 8. So using GeoGebra to get this, we would have 15 over 2 minus 2y equals 8. What I'm going to do is multiply everything by 2 here, just get rid of the fraction. So that would give me 15 minus 4y equals 16. Or you could go ahead and do in the calculator 8 minus parentheses 15 divided by 2 parentheses with your fraction text. Here I'm going to subtract 15 from both sides, so I'll get negative 4y is equal to 16. That's 1, sorry. And when we divide by negative 4, we'll get y is equal to negative 1 over 4. So our solution would be 5 over 2 and negative 1 over 4. So you'll notice graphing is only really useful when we get those nice whole number answers. For anything with fractions, we're going to have to rely on our algebraic solve. All right, so this one, looking a little different. We notice that we have x's and y's are both different numbers. So, easiest thing to do is pick one and go with it. So I'm going to try to just get rid of my x's. That's when it's not set up nicely, that's usually the easiest way to do it. So, if I want to get one of these, I want to make each number with opposite signs. Well, I know 5 times 2. I'm going to multiply the entire equation by negative 2. Multiply negative 16 positive 16y. Multiplying these negative. And if we add here, we tend to let's go ahead and divide fraction text here to get this reduced if you don't like doing it by hand. It would be 10 over 16, that goes to 5 over 8. Alright, so from here we can plug that in. So I'm just going to use the top one. So I have 10x plus 16 times my y here, so 5 over 8 is equal to 140. That gives me 10x. So in GeoGebra, I would type 16 parentheses 5 divided by parentheses. And again, if you put that inside of your fraction text, you'll get a nice answer here, and it'll just come out to 10. We subtract our 10, and I'll get 10x is equal to 130. Divide by 10, and I'll get x is equal to 13. So my answer is this one. Always include our x, comma y, so 13, comma 5 over 8. Alright, moving on. Alright, so for this one, a little more work. I'll actually do this one with you guys. So I need to get my x over here. So I have my x and y on the same side. So I would add it. So I'm going to leave my top one the same here. So I have 3x plus 2y equals 8. So when I add it over, then I would have positive 5x, and it's a positive 2y is equal to 12. Now with this one, our x's are different, our y's are different. But I notice the y's are the same number. So what I could do is just multiply that bottom equation by negative 1. So that'll give me, leave my top the same at 3x plus 2y equals 8. And if I do negative 1, it just changes the sign. So I'll have negative 5x minus 2y equals negative 12. Then I can add and get some cancellation. So here, this gives me negative 2x. My y's cancel out, and it's equal to negative 4. Dividing by negative 2 will give me x is equal to positive 2. And let's go ahead and plug in here and use the first one again. So 3 times my x, which is 2, plus 2y equals 8. So that's 6 plus 2y is equal to 8. I subtract 6 from both sides and get 2y is equal to 2. Divide by 2 and get y equals 1. So my answer, x comma y. Alright. Let's go ahead and do this one as well. Okay, so I'm looking here. My x's are different, my y's are different. Now, if I just have an x, remember we always have that imaginary or the placeholder of a 1 out front. So there's a couple ways we could do this. We could multiply the bottom by 2. We could do a couple different things to get our y's cancel. But let's say we don't know that by hand. I'm just going to cancel my x's. So I have a 1 and a 5, right? So this means I can multiply the top one by negative 5 to get my x's to cancel. So that'd be negative 5x plus 40y. So negative negative equals 40. And my bottom I'm going to leave the same because I didn't do anything to it. So when I add my x's cancel, I get 44y is equal to 44. I divide both sides by 44 and get y equals 1. Go ahead and use the second equation to solve for my x. I'm plugging my 1 for y. I get 5x plus 4 is equal to 4. Subtract, I get 5x is equal to 0. Divide by 5, and I'll get x is equal to 0. So my solution, 0, comma, 1. All right. I'm going to go ahead and skip over these. Move past this. We already solved with elimination. Okay, so now I want to talk about the 3 different outcomes we referenced at the beginning of the video. So when we have these nice linear equations, meaning the variables are the first power, there's nothing squared, what that means is we have 3 different outcomes. One solution is what we've seen so far, means the lines intersect exactly at 1 point. No solution means when the lines are parallel, so their slope is the same. Infinitely many solutions means both lines are actually the same line, they just might look a little different in their equations. Skipping over these. Alright. So let's go ahead and solve these next 4 algebraically. So as far as the test goes, unless it directly tells you that you're allowed to use substitution, or graphing I should say, that means we have to go ahead and solve these things algebraically. Alright, so for this one, here's where we'll review a bit of our substitution. So actually, you know what? Let's just stick to elimination. It's a much cleaner method, and now we're going to cover all the tools we need to do it. So here, I need to get my x and y on the same side. So this one already has x and y on the same side. This one does not. So I need to move this. It's a negative 3, so I would add 3x to both sides. So that would give me 3x plus y is equal to negative 1. Now if I look, these are the exact same equations. Since they're exactly the same, what that means is I have infinite solutions. Now sometimes we're not going to be able to see that right off the bat. So let's go ahead now and use elimination to solve this, just so we can see what kind of statements also imply infinite solutions. So here, if I wanted to cancel out, right, I would let's say I'd multiply the bottom one by negative 1. So when I add these 2, I can cancel out my x, so I'm just going to rewrite this a bit. So my top equation was 3x plus y is equal to negative 1. My bottom, once I do that negative 1, would give me negative 3x minus y is equal to positive 1. So I add, my x is canceled, so that means I'm left with 0. Negative 1 and 1 also give me 0. So if I get a statement that's always true, so I get something like x is equal to x, y equals y, 5 equals 5, negative 50 equals negative 50. If it's a statement that's true, that's another way to see of infinite solutions. In contrast, if I have a statement that's false, such as 5 is equal to 2, so if I get one number equals another number and it's just not true, what that means is we would have no solutions. so let's go ahead and work through this one now. So, let's see, my y's are different, x's are different, so let's go ahead and cancel our x. So I have a negative 2. That means if I multiply the entire top equation by positive 2, so I'm going to rewrite that down here, I'd get 2x minus 4y equals 10. So multiplying that 1 will give me 2, negative 4, 10. So now I'm going to go and add these two here. So my x's cancel, my y's cancel, so I get a 0, and then I get 12. So this is an example of a false statement. Since 0 is not equal to 12, this is an example where we have no solution. So these lines actually never intersect one another. So these would be parallel lines. So no solution also implies we have parallel lines. All right, check out these two. So here, let's see, cancel my x's. So to get 2 is 4. Let's go ahead and multiply it by negative 2. So I get negative 4x minus 2y equals negative 8. When I add those, I get 0. This gives me negative 4y equals negative 8. Cancel. My y's will also not cancel. And then here, we have our negative 8. I divide both sides by negative 4 and get y is equal to 2. Then if I plug back in, so let's use this equation here. So 4x minus 2 equals 0. 4 to both sides. Divide by 4, x equals 1. So this one, nice one solution here. 1, 2 like we've seen before. So again, if you're getting that work down. All right, let's go ahead over here now. So we're good. My x's and y's are on the same side. Let's see here. So let's say I didn't realize what I could do to get rid of my y's. So let's stick with my x's, right? I know 4 times 3 gives me 12. So if I multiply it by negative 3, I'm going to rewrite that down here. They give me negative 12x plus 3y is equal to negative 15. Then let's add these cancel, so I get a 0 equals negative 5. That's definitely not a true statement. Therefore, we have no solution. And again, we can think of those as being parallel lines. All right, moving right along here. Okay. All right. So we're not actually going to solve these by graphing. Just real quick, let's kind of talk about what they look like. So in our first scenario here, now that we have non-linear, so meaning we have some parabolic stuff, some x squared type things, we again have 3 scenarios. So the first here would be 2 solutions, meaning it intersects twice. So there's 2 points where that curve hits the line. This cannot happen with 2 linear equations, but it can when we have parabolas, when we have a squared and a linear. We could have no solution, just like before, so we arrive at a false statement because these two never touch one another. And lastly, we can have 1 solution. So we have a case where the parabola intersects the line at exactly 1 point. All right. Let's go ahead and skip over some stuff here. All right. So we're going to talk about a couple different methods to solve here. So things to come up with, we're going to touch on a little bit of substitution here. So when we get to these squared or nonlinear equations, sometimes substitution is very favorable. So we'll utilize that. We're also going to need to use that quadratic formula. So again, in most math classes, it's an expectation that you have that memorized. I'm also sorry, I just said expectation, really weird there. But for our purposes, you can assume this will be written on the board for this test as well as any others that involve it. So take a moment right now and just make sure you pause the video and write down that quadratic formula on the top of your page. So let's start here. All right, so we notice right off the bat we have one equation that's linear. And then this one is going to be quadratic because it's got that squared x variable. So as we go to solve these, we're going to need to employ a little bit of different methods. So first thing we notice is both equations are solved for y. So to utilize substitution, since both equations already have y by itself, we're thinking about setting these two sides equal. So again, y has to be by itself on both sides to employ this method. So here I have 5x plus 12 equals x squared plus, you know what, real quick, erase what you have. Let's always just put our quadratic equation on the left. So the thing with the squared variable, let's put it on the left. You'll understand why. Let's make the work a little bit cleaner. So equals 5x plus 12. Now, to utilize the quadratic formula, I need to get things set equal to 0. So I'm going to move all my variables to the left. So let's start with subtracting 5x. And notice I'm lining it up with my x variable. So that gives me 5x squared minus 3x minus 6. And it's positive 12, so I'm bringing it down. Now to get 0 on my right side, I'm going to subtract 12. So that would give me x squared minus 3x minus 18 is equal to 0. Take a moment now and ensure you have that down. For the sake of space here, I'm actually going to erase mine. But again, you don't want to erase it. You need all the work. Write it up here. So x squared minus 3x minus 18 is equal to 0. All right. So at this point, you might be able to factor this. So let's say we had factoring. If I factored this, this would get me a, and again, well, I'm going to show you both methods, but if I factored, we would end up with something like x minus 6, x plus 3 is equal to 0. But let's say we don't like factoring. We want to go to a way to solve this. We can always go to quadratic form. So here my a is what's up front. Nothing's there, so it's a 1. b is negative 3. c is negative 18. So factoring works sometimes, and if you're quick at it, that's great. If not, I would just go to quadratic form because it'll always be this right. 3 plus or minus square root b squared minus 4ac all over 2 times a. So we've talked before about putting this into GeoGebra without the square root symbol. So if we go ahead and do that, so we have negative 3 squared minus 4 times 1 times negative 18. So I have, now let's go ahead and clear all this out. Oops. Delete. 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 All right, so negative 3 squared minus 4 times 1 times negative 18. So negative 3 squared minus 4 times 1 times negative 18. Good. I get 81. So this will 3 plus or minus 81 over 2. Not even, so it's not divisible by 2. So I start checking the next number. It's divisible by 3. So 3 is one of those primes we've talked about a lot. So 2, 3, 5, 7, 11, 13. 2, 3, 5, and 7 are big ones. So I divide it by 3, and that gives me 27. I check. It's not even, but it's divisible by 3. So 3 and 9. And 9 breaks down to 3. I have all my primes right in that nice pattern we talked about. So I need a pair of numbers to take one out. So I have a pair of 3s, another pair, and nothing left over. So I get, and I lose my square root because I have nothing left in our circle here. 3 times 3 is 9. This gives me x equals 3 plus or minus 9 over 2. I'm going to go ahead and erase this. I'll make sure you have this down just for sake of room here. All right. So what we're going to do is actually take this a step further now and actually solve for our solution. So I have x equals 3 plus or minus over my first 3 plus 9 over 2. And then for my second one, it'd be 3 minus 9 over 2. So, and the reason we're going to take this step is because this turns out to a nice whole number. If we ever have something left over with a square root or an I or anything that's not a whole number essentially, we're just going to go ahead and leave it just how it looks like we have in previous units with the plus or minus. But since we got down to a whole number, we're going to go ahead and simplify. So here, if I do the top first, that's why you notice I put parentheses there, so this is important. So 3 plus 9 is 12 divided by 2. Here I get 3 minus 9, that's negative 6 divided by 2. So my x's are going to be, if I divide here, this reduces to 6, that's negative 3. So again, these problems do require a lot of work. So let's go ahead now and find our order. Alright, so we got our 2x values, so now we need our 2y. So I'm just going to plug into the first one because it's linear. So we always want to plug that into our linear equation. Times my negative 3. So I simplify this. Plus 12, which is negative 3. So my two solutions are x is equal to 6, comma 42, and x is equal to negative 3, comma negative 3. So those are representative of our two solutions to this equation where it intercepts it twice. Take a moment now and ensure you have all that worked out. All right, let's go ahead and move on here. So again, we have both equations solved for y, so we're going to employ substitution. So this gives me my quadratic, 2x squared minus 4 is equal to 4. So is it a 4 here? So if I go ahead and subtract that 4 over, I get 12x squared minus equal to 0. Now, if we think about our quadratic here, we notice we have an x squared term, but no x term. So this is the same thing as saying I have 2x squared plus 0x minus 8 is equal to 0. So a couple methods of solving here. If you remember our square root property, I would know that I could add 8. I'd actually add 4. So if I want to solve one way, I could add this over. So I'd get 2x squared is equal to 8. Divide both sides by 2. Get x squared is equal to 4. Square root, I get x is equal to positive or negative square root of 4. Break that down and get x is equal to positive or negative 2. But let's say we were bad at this. It was challenging for us. I really like quadratic formula. So I'm going to leave that up for now if you want to copy that down. But let's go back here and do quadratic formula. So we talked about having a 0. So that gives me my a is equal to 2. My b, since it's not there, is 0. And my c is negative 8. So take a moment now, get that down. So pause the video, and then we'll come back to solve. All right. So I'm going to go ahead and erase all this now. So we have our a, b, and c here. So that gives me x is equal to the opposite of b. Well, opposite of 0 is still just 0. It's oddly enough the only number in the entire number line that has that property, where its opposite is itself. It's also my daughter's favorite number. So b here is going to be 0 squared minus 4ac all over 2a. So this 0 plus or minus actually goes away. So here I just have plus or minus. And if I did this in geometry, 0 squared minus 4 times 2 times negative 8, which would give me positive 32 all over 4. So we get positive 32 over 4. Now let's see if we can break this down a bit more. 32. So go ahead and break that down, right? So that's 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I have my 2's here, which means I could take out 2 pairs and be left with my square root. Take here. So actually, if I multiplied this, my bad, I did that wrong. This should be 64. So if we break that down, go ahead and correct this a bit here. I'd get 2 and 32. And I'd have 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. So I have 1, 2, 3, 4, 5, 6 2s. So I'm taking out my pairs, which means I could take out 3 of these, which is going to give me 8. So this would give me x is equal to positive or negative. We lost our square root. 8 over 4. And then if I solve this, that would be, let's go ahead and erase this. So pause it if you need to get to work. So I'd have positive 8 over 4 and negative 8 over 4, which give me 2 and negative 2. So we're getting those same answers as we had before. So you'll notice no matter which way you solve this, assuming you don't multiply wrong in your head here, you'll get the exact same answers. So if I plug those in, we have our linear one here with no x's. So what that tells me is no matter what my x is, my y is equal to 4. So I have 2 and 4, because then it's y equals 4 here, kind of a special case. And my other solution would be negative 2 and 4. All right, moving along. So here we have both y equals again, so let's go ahead and start solving. So I have x squared plus x minus 7 is equal to 3x minus 2. I'd subtract my 3x from both sides, which would give me x squared minus 2x, because remember there's a 1 here, minus 7 is equal to negative 2, because it's minus here. So then I'd add 2 to both sides. I'd get x squared minus 2x minus 5 is equal to 0. This one, no matter how hard you try, won't actually factor. So what that means we have to do is solve using quadratic formula anyway. So I have my a is 1. Oh, no, I wrote x is 1. A is 1, right? So I have b is negative 2, c is negative 5. So opposite b plus or minus square root b squared minus 4ac all over 2a. So as we start simplifying, I utilize GeoGebra here. Be square root of 24 all over 2. So that'd be 2 plus or minus. If we break this down, I'd have it's even, so divisible by 2 and 12. And I divide it again by 2 and 6. And I get 2 and 3. So let's see what we can take out here. Take out a 2, and I'm left with a 2 and a 3. So that'll give me 2 root 6. And last thing we want to check in this unit as we expand our knowledge a bit here is if we can reduce anything. So I notice all 3 of these coefficients are 2. So if I divide everything by 2, that would give me, well, 2 divided by 2 is just 1. And then that goes away, so it's just square root of 6. You know what? For our purposes, we're totally fine here. And since we have really, really ugly solutions here, it's x plus or minus something with a square root, we can just go ahead and leave it just how it looks here. So if it's really ugly, don't worry about plugging in. I'm concerned that you can solve to this point. So other ones, if they came out to whole numbers, we reduced. Here, since we're left with quadratic formula at this point, we're just going to leave it how it looks. All right, let's go ahead and do how many more of these we got. Let me just do a quick check here of what we got left. All right, let's go ahead and do like 2 more of those. Now, skip that one. Let's do one more good one, right? Okay, so we have x squared minus x plus 3 is equal to 2x plus 2. I subtract 2x from both sides, giving me x squared minus 3x plus 3 is equal to 2. Subtracting 2 gives me x squared minus 3x plus 1 is equal to 0. So with our quadratic formula again, we have x is equal to the opposite of b plus or minus square root b squared minus 4ac all over 2a. So utilizing GeoGebra here, I'd have 3 plus or minus, that'll give me square root of 5 all over 2. And we see we have a square root, so we know we are done. So again, when we're left with a square root in the quadratic formula, I am totally fine with us leaving the answer as that. All right, move on along here. So these will be left up to optional practice should you so choose to do them. And I would be more than happy to check your answers if you'd like. As well as this one up here. So I'm going to go scroll real slow here so you can kind of get them down if you want. I'm fairly certain these are available in your notes, but again, if they're not, pause the video, write them down, come up to my desk, ask me. I'd be happy to make sure that you try. Let's skip over this. All right. Now we are going to do some linear equation word problems. So you guys actually seen these back in Algebra 1, but we're going to go ahead and go through now and just make sure we have these all down pat. So we had 1, 2, 3, 4, 5, 6. All right, so we have 6 examples to get through, and that'll conclude these notes. We're actually going to do all these together just to make sure we have a good grasp on them and are prepared for our exam. Okay, so in the fall, the Math Club and the Science Club each created a website. So we have 2 different things we're talking about here. You are the webmaster for both sites. In January, you compare the number of times each site is visited each day. For the Science Club, there are currently 400 daily visits, and the visits are increasing at a rate of 25 daily visits per month. For the Math Club, we have 200 daily visits, and the visits are increasing at a rate of 50 daily visits per month. Write a system of equations to represent the number of daily visits V to each site for T months since January. Okay, so we're thinking about how many visits each month. So let's think about our first one. So let's talk about the Science Club first. Let's call it our S equation and our M equation. So it says V visits, so we're going to start off with our capital V for both. Now, for the Science one, it says we have 400 daily visits. So we're starting off with 400. And it's increasing, so that means plus 25, and the word per here means multiply. So it says T months, so we're going to go with 25T. The next one, it says 200 daily visits from the math side and increasing at a rate of 50, so plus 50T. Let's go a step further here, and let's say we want to solve these. So when these 2 things are going to be equivalent. So I would have them both solve for V, so I could just set them equal. So it would be 400 plus 25T is equal to 200 plus 50T. So let's say I want to move my T's to the left. So I'd subtract 50 from both sides and get 400 equals minus 25T is equal to 200. I could subtract 400 and get negative 25T is equal to negative 200. And when I would divide by both of these, I would get T is equal to positive, because negative 200 divided by negative 25 gives me a positive 8. So I'd know that after about 8 months, those visits would be equal. Now again, it didn't say to solve, but always good practice. All right, example 2. We have Karen and Jennifer have summer jobs selling newspaper subscriptions door to door. But their compensation plans are different. Karen earns a base wage of 7 per hour, as well as 2 for every subscription that she sells. Jennifer gets 4 per subscription sold, in addition to a base wage of $5 per hour. Write a system of equations to represent compensation C for selling S subscriptions per H hour, or per hour H. So we'll notice the difference here. Here we had 2 variables. That told me I could set it up like this, where one is equal to something involving the other. This one's giving us 3 variables. So first step, I can always set it up where I have these 2 ideas. So I have Karen, and I have Jennifer. Now, we notice we have a capital C, so that kind of gives us our idea where we start. So we're going to start with C equals something. So for Karen, we said 7 per hour. So H is our hours, so that would be 7H. Well, notice the word per here is used twice in each scenario. And then it says she gets 2 for every subscription S, so plus 2S. Jennifer gets 4 per subscription, so let's go ahead and line them up. We get 4S, and 5 per hour H. So again, 3 variables means our setup's going to look a little bit different. So 2 variables is going to look like this, 4 variables like this. All right, let's go ahead and solve here utilizing some eliminations. Just make another color pen. There we go. So if I multiply the top one by negative 2, I can cancel out the bottom one here. So it's going to give me negative 14H minus 2S. Actually, you know what? We're not going to go ahead and solve this one because we actually don't have enough information to. You know what? Let's solve it a bit different way here. Instead of using elimination, we have them both solved for C, but we only have 3 variables, not enough information. So this one actually we can't solve as is. We'd have to figure out like when will they make the same amount of money or the same amount of compensation, or if they set these 2 equal. So in this scenario, we're not given enough information to actually go ahead and solve this problem. And obviously on a test, I wouldn't ask you to solve something you have enough information for. This one right here, we're going to leave up to optional practice. So if you want to try this try here about field trips to Great America, feel free to do so now and then come up and check with me, and I'd be happy to tell you if you're right. Otherwise, you may move on with the video. Same thing here with this one. So I'm going to suggest that you guys go ahead and try these now because they're really similar to the first two questions. This one will look like our second example, and this one will look like our first. So if you want to go ahead, actually I lied. This is the second example. This is the second one we did. This is the first example. So if you want to go ahead and try those now, you can, and I'd be happy to check your work with you and make sure you're doing them right. If you feel comfortable with them, then you can move on. All right. So this one, we'll notice both of these are asking us to do a little bit more work. Last example here, we'll notice this one's got two parts. We're actually end up solving is asked by the equation. So we have Kristen School selling tickets to the musical. On the first day, the school sold 2 adults and 8 students for a total of 120. The school took in 96 on the second day by selling 2 adults and 6. So first, let's go ahead and set up our equations here. So it says X representing the number of adults and Y representing students. So for the first scenario, all right, so for the first one here, we have 2X and 8 students, so 8Y is equal to 120. Next one, we sold 2 adults and 6 students for a total of 96. So that's our equation. Now it says, what is the price of each one adult ticket and each one student ticket? So that means we need to solve here. So if we use some elimination, equation by -1 to get the x's to cancel. So I get 2x plus 8y is equal to 120. Then -2x minus 6y is equal to -96. Combining here, we have these canceled, and I'd get 2y is equal to positive, let's see, for 24. Then if we go ahead here and divide, I'd get y is equal to 12. So now to figure out the other side of this, I would take either of my original equations and plug in. So that'd be 2x plus 96 is equal to 120. Subtract 96 from both sides. Dividing, I get x is equal to 12. So here in this scenario, both our student and adult, this is our adult, our x's, and our student here, are $12. Take a moment, ensure you have all this down, and at that point, I would 100% suggest trying to solve this problem, which is really similar to the example we just did, and then check it in with me. So pause the video now and begin this problem. After that, we are all good. So this will conclude the notes for this Unit 6. Make sure you have everything down here, and then feel free to come check everything with me, begin your practice, use that answer key there to make sure those are good. And before you know it, we'll be going ahead and reviewing as a class to take our Unit 6 exam.